All right, the first part of exercise 8I here is we're going to be solving for x when it's a variable. Each of these 1 through 6, actually 7, and then part of 8. We'll get there in a second. Solving for is a variable. When the question involves a right triangle with two sides and an angle measure. On some of the questions, the side is the variable. In this case, the angle is a variable. But when we're talking about two sides and a variable, regardless of where the variable is, that's where we're using sine, cosine, and tangent. So from the perspective of our angle, here x, 5 is opposite, 14 is the hypotenuse, so that's the sine, SOH, sine is the opposite over the hypotenuse. So write your equation, sine of the angle equals the opposite over the hypotenuse. To get x by itself, this is where we do the inverse of sine, which is called the arc sine. It looks like this. So when I do the arc sine of both sides, I get rid of the sine that's next to the x, and I end up with arc sine of the ratio 5/14. Type that into your calculator. This is your answer. What is the ratio here in this case for this guy? 8 is the hypotenuse, 5 is the adjacent side. Adjacent and hypotenuse, CAH, that's the cosine of the angle equals the adjacent over hypotenuse. So again, now to solve for the angle, this is where we do the arc cosine, in this case, of both sides. So the arc cosine of 5/8, type that into your calculator, you get this answer. These instructions say to round to the nearest hundredth. So do that. From the perspective of the angle here, 6 is adjacent, 13 is opposite. This is the hypotenuse. Over here we don't know what it is. So which one uses adjacent hypotenuse? That's tangent. So the tangent of the angle is equal to opposite over adjacent. Then we to solve for the angle x, x equals the arc tangent. So every time we're solving for the angle measure, when the angle measure is x, that's where we use the arc sine, arc cosine, arc tangent. In this example, angle here is x, 3.0 is the adjacent, 5.8 is the tangent. Is the hypotenuse. So we will use the cosine, adjacent over hypotenuse, and then use the arc cosine of both sides. Number 5 here has something you got to be a little careful about. This is 3 is the adjacent, 3 square root of 5 is the hypotenuse. So when you do this one, do the arc cosine. 3 square root of 5 you have to put parentheses around the 3 and then after the square root of 5 because all of that goes on the denominator. When you do this, you'll get an error, or at least probably an error, I think, if you type it in the wrong way. On to the next one. Here, 36, 10 is the opposite, x is the hypotenuse. That is sine, so we do the sine of 36 equals 10 over x. Notice now the angle isn't the variable, but x is the side. So now the sine of the angle equals 10 over x. When you have the variable in your ratio here, this is where we should make this to proportion, to where we should either cross multiply to get x with the 1, x over 1, or x times 1, or switch the extremes. In this case, I need to switch the extremes to put the x over the 1 and the sine of 36 on the bottom. So x equals 10 divided by sine of 36. Type that into your calculator. Number 7, it's like a buy one, get one version, like we say. There's just two questions in one. Here's a right triangle. X is the angle. That's the opposite. That's the adjacent. The hypotenuse is this guy over here, so that's tangent. Whereas in this case, with this angle, 3 is adjacent, 5 is opposite, so that's also tangent. So we're just solving for each of those variables that way. Now, number 8. Do you see that number right there? That's 30 degrees. So this is a 30, 60, 90 triangle. It's best then not to use sine, cosine, and tangent, but to use the stuff that we learned about 30, 60, 90s. 6 is the hypotenuse, W is the short leg. Do we multiply or divide to go from the hypotenuse to the short leg? We divide. Divide by what number? Divide by 2. We get the W is 3. Now that I know that W is 3, I can solve for x. In this triangle here, that is a right angle. We know that because the alternate interior angles are equal. It's a right angle. So 4 is the hypotenuse, W is 3. So I can say the arc, the cosine of the angle is equal to 3 over 4, and then the arc cosine of 3 over 4. This guy is isosceles. So that altitude chops x here in half. I'm going to call that y so that I can solve for that piece. I don't want to call it x because this whole thing here is x. So I need to go, the cosine of 42 is equal to the adjacent side, y, over the hypotenuse, 102. Here I will cross multiply. Y times 1 will equal 102 times the cosine of 42. That gets me 75.8. Which I will multiply by 2, because that's y, 2. Both of those are 75.8. So put those together, you get 105.6. To solve for w, I will use sine. The sine of 42 equals w over 102. And the triangle on the left will get you that answer. In our corona world right here, we're not going to worry about these particular questions. But I'll just tell you this, angles of elevation always come up from the ground like this. We're just always going to be making a right triangle with it. Angles of depression come down from horizontal like this, but then always will equal this angle of elevation down here at the bottom. Angles of elevation always come off the ground. Angles of depression come off of horizontal downward and then equal those there, alternate interior angles. But this ends up just being a right triangle thing that won't show up on a quiz or a test in 2020. All right, other side of the page gets good. This is the simplifying for sine, cosine, and tangent. Number 3, that's supposed to be solving for KH right here, or number 13, that is. And how would you do this? Pythagorean theorem. Pythagorean theorem. Some x squared plus square root of 6 squared equals square root of 15 squared, and that's 3. So the sine of angle K, square root of 6 over square root of 15, and then, yep, we got to simplify. That ends up being square root of 10 over 5 because, please reduce it, that's your best move. Square root of 2 over square root of 5, multiply by square root of 5 over the square root of 5. That's our answer. Sine of G ends up equaling the square root of 10 over 5 as well, same thing. Tangent, opposite over adjacent. Here, the sine of G is 3 over the square root of 15. We've got to do some work. We end up with square root of 15 over 5. Certainly, it's whenever we have the radical on the denominator, that's where we got to do the most work, like these guys are. But make sure you know your SOHCAHTOA. Okay, the next part of this is putting it all together review, like for our test that we're going to be taking here shortly. This is the geometric mean question because I have the big triangle is the right triangle with the altitude coming through here. So x is the geometric mean between 10 and 6. It shares a triangle with both of those. 2 square root of 15 is the answer. On this guy, this is a right triangle, of course. X is a side, 10 is a side, 26 is a side. What do we use when we know 2 sides and don't know the third? Pythagorean theorem. Here, x is a side, 10 is a side, 26 is an angle. When you only have one side but have an angle measure, sine, cosine, and tangent. In this case, from the perspective of 26, 10 is opposite, x is adjacent. Solve. On the next guy, x is here, it's an angle. 26 is the hypotenuse, 10 is the adjacent, that's cosine. But because x is the angle, how do we get the x by itself? Arc cosine. And this guy, 30 degrees. So now I'm going to go through our 30, 60, 90 process. That's 26 to go from 26 to 13. That's hypotenuse to short leg, divide by 2. Short leg to long leg, multiply by square root of 3. Here's a sine, cosine, tangent because of the angle and the side, the variable. The tangent of 26 equals x over 10. Go solve. I'm not sure what that was supposed to be. Never mind, I know what that is. Here, then this is x down here, 10 squared plus 26 squared equals this. We end up with a big number that we're solving for. 2 square root 196 is the solution. And then the rectangle question. Always be prepared for this one. When you see those right angles, make a rectangle. 30, 60, 90 triangle makes this 7. This hypotenuse to short leg becomes 7. This was 6 because of that side 6, so that y becomes 13. 7 plus 6 is 13. Then x is the same thing as this x over here because of the rectangle. Short leg to long leg, 7 square root of 3. And finally, number 27, if the perimeter of an equilateral triangle is 36, then each of the sides is 12. The altitude chops that 12 in half to get 6. The altitude there is always going to be the long leg of that 30, 60, 90 triangle. 6 times the square root of 3 is 6 square root of 3. If you have other questions, let me know, but hopefully that was helpful. Thanks, bye.